Good morning, my dear students. Welcome to Agial International Language School with the first session in the second term. Today we are going to talk about the oscillatory motion. The oscillatory motion. First, the periodic motion defined as the motion which is regularly repeated in equal periods of time, like oscillatory motion and wave motion. To understand the concept of oscillatory motion, try to make a simple pendulum like this. Pull the metallic piece which represent the oscillatory body. Now this piece represent the oscillating body. Pull it to the right side, then leave it. Record the time taken by the metallic piece to repeat its movement several times. You will observe that the oscillating body moves in both sides around its rest position from A to B and B, C. The motion is repeated in equal time intervals. The displacement of the oscillating body around its rest position are equal, and the velocity of the oscillating body reach its maximum value when it passes its rest position and decrease gradually when it goes far from it until it reaches zero at maximum displacement on both sides of the rest position. So we can conclude that the oscillating body moves around its rest position where the motion is repeated through equal interval of time, which is known as oscillatory motion. So we can define oscillatory motion. It's a periodic motion of the oscillatory body around its rest point where the motion is repeated through equal intervals of time. The relation between the velocity of an oscillating body and its kinetic energy. From this relation, the kinetic energy equal half mass by velocity square. This means that the kinetic energy of the oscillating body is directly proportional to the mass of the oscillating body and the squared velocity of the oscillating body. So the kinetic energy increases when the velocity of the oscillating body increases and vice versa. We have different examples of oscillatory motion, like stretched string, motion of swing, spring, tuning fork, and pendulum. Remember that the motion of the rotary pea is considered as a periodic motion because it's repeated regularly at equal time intervals, but it isn't oscillatory motion because it's not repeated on the two sides of its rest position. The graphical representation of the oscillatory motion can be represented like in the following activity. Try to make a device like this using spring, weight, holder, and a pencil. The pencil will draw the shape of the oscillatory motion on the paper tab as shown, and the motion of the weight, which is called simple harmonic motion, is considered the simplest form of the oscillatory motion. So the graph will be like this. In the simple harmonic motion, the velocity of the oscillating body is inversely proportional to its displacement away from its rest position. That means that the velocity of the oscillating body increases as it approaches the rest position and vice versa. The properties of oscillatory motion can be expressed in many concepts such as amplitude, complete oscillation, periodic time, and frequency. First, amplitude. In the simple pendulum, the maximum displacement that the pendulum makes when it oscillates from its rest position on the left side at point B. The displacement AP is equal the displacement PA. Also, on the right at point C, the displacement AC equals the displacement CA. So, the displacement AP will equal the displacement AC. Each of displacement AP, BA, AC, CA is called amplitude. AP is called amplitude. Also, BA, AC or CA are called amplitude. This means that the amplitude is the maximum displacement done by the oscillating body away from its rest position, and its measuring unit is meter. So, when you have a question, what is meant by the amplitude of an oscillating body is 20 centimeter. This means that the maximum displacement of oscillating body away from its rest position is 20 centimeter. By another way, the maximum displacement of oscillating body is 4 centimeter. This means that the amplitude of the oscillating body equal 4 centimeter. Number 2, complete oscillations. The motion of oscillating body when it passed by a fixed point on its path 2 successive times in the same direction. So, when the pendulum moves back and front, like this, from A to B, number 1, and from B to A, number 2, then from A to C, then from C to A. And when it begins to repeat its movement again from A, we can say that it has made a complete oscillation. From A to B, this point, number 1. After that, from B to C, number 2. From C to B, number 3. From B to A, again, number 4. So, this is called a complete oscillation. From A to B is called amplitude. So, amplitude equal 1 over 4 complete oscillations. And 1 complete oscillation equal 4 multiply amplitude. Exercise. In which graph the amplitude is larger? Graph A or graph B? Amplitude of curve A is larger than the amplitude of curve B. From here to here is 1 amplitude. But in B, from this point to this point is 1 amplitude. How many complete oscillations do exist between the points on both graphs, point X and point Y? In curve A, we have from this point 1 amplitude, 2, 3, 4. So this 1 complete oscillation. Another 1. So we have till now 2 complete oscillations. And this is number 3. So in graph A, we have 3 complete oscillations. While in graph B, from X to Y, this is 1, 2, 3, and 4. So we have 4 oscillations. We have 4 complete oscillations. Number 3 and 4, they are periodic time and frequency. Periodic time and frequency. Periodic time means the time taken by an oscillating body to make 1 complete oscillation, and it has a measuring unit second. While frequency means the number of complete oscillations made by an oscillating body in 1 second, and it has a measuring unit hertz, related to the German science hertz. Here, the time taken by an oscillating body to make 1 complete oscillation from this point to this point is called peridoctype, while the number of complete oscillations made by the oscillating body in 1 second is called frequency. Peridoctype can be calculated from the relation time in seconds over number of complete oscillations, while frequency can be calculated from the relation number of complete oscillations divided or over time in seconds. Remember that the value of the peridoctype will be equal to that of the frequency when the number of complete oscillations made by the oscillating body equal to the time taken by the second. So when you have questions, what is meant by the time taken by a spring to make 60 complete oscillation is 1 minute. This means that the periodic time of this spring is 1 multiplied 60 over 60, which equal 1 second. Number 2, what is meant by the periodic time of an oscillating body is equal 0.2 second. This means that the time taken by this oscillating body to make 1 complete oscillating is 0.2 second. Number 3, what is meant by the number of complete oscillations made by an oscillating body in 1 minute is 60 complete oscillations. This means that the frequency of the oscillating body is 60 divided 1 multiplied 60, which is equal 1 hertz. Number 4, the frequency of an oscillating body is 20 hertz. This means that the number of complete oscillations made by the oscillating body in 1 second equal 20 complete oscillations. The relation between periodic time and the frequency can be calculated from the relations. Number 1, periodic time equal time in second over number of complete oscillations, while frequency equal number of complete oscillations over time in second. By multiplying the two previous equations, we find that periodic time multiplied frequency equal 1. So periodic time equal 1 over frequency, while frequency equal 1 over periodic time. So the frequency is inversely proportional to the periodic time, which means the frequency decreases by increasing the periodic time and vice versa. Remember that kilohertz, first the fraction of hertz are kilohertz, megahertz and gigahertz. Kilohertz equal 1 multiply 10 power 3 hertz, while megahertz equal 1 multiply 10 power 6 hertz. Gigahertz equal 1 multiply 10 power 9 hertz. Thank you and goodbye. See you the next time, inshallah.